to sketch, h of x is equal to 2x times x plus 4 to the third times x minus 1 to the... Okay, why is this nice? This has already been what? Factored for us. Okay, to start, we want to figure out which quadrant we're starting in and which quadrant we're ending in. The way we figure out which quadrant we're starting in and which quadrant we're ending in is we need to look at the total degree of the polynomial if it had been multiplied out. How are we going to do that? Well, if it would be multiplied out, this is a degree of 1, this is a degree of 3, and this is a degree of 1. Do you agree? So when you distribute in, what would be the highest degree? The first times the third times the first, which is a total of 5. So the degree of the polynomial is odd. And do we agree that it's positive? The leading coefficient would be positive. So what does that mean? We're starting, so we're odd and positive. So where are we starting? Where are we ending? Who remembers? Right? Think of a line. Matt? Yep, we're starting here. Think of a line, and we're ending here. Okay, so now what we're going to do is we're going to find our zeros. Now we're going to find our zeros. So I'm going to take our polynomial that's already factored for us. I'm going to set it equal to 0. So now we get 2x is equal to 0. Is this a single root, double root, or triple root? Single root. SR, single root. What does a single root look like? A line. All right, where do we have a single root? At x equals 0. Plot it. All right, now I have x plus 4, that whole quantity cubed equals 0. What is this? Single root, double root, triple root? Triple root because the exponent's 3. It's a triple root. So I'm going to write TR. What does a triple root look like? The disco dancer, right? Disco dancer. So now we're going to cube root both sides. So we're going to get x plus 4 equals 0. So x will equal -4. And then what about x minus 1? Is that single root, triple root, double root? What is it? Single root. What does a single root look like? A line at x equals 1. All right, let me plot the remaining points. We get x equals -4, 1, 2, 3, 4. And we get x equals 1 right here. Okay, so now when we start to sketch our graph, we're going left to right. We're going to go left to right. So my furthest root on the left was x equals -4. What was x equals -4? Wasn't that the disco dancer? Right, so what we're going to do is we're going to draw a disco dancer through that root. And we're going to start in quadrant 3 because this is where we're starting, and I'm going to go up. So the curve happens. The disco dancer is the hardest one to curve. Instead of just curves at the 0. Okay, but now I need to turn, right? How do I turn? Do I turn with a V or do I turn with a curve? Turn with a curve. So now I need to turn with the curve and go through my next root, which is 0. Isn't that a single root, which is a straight line? So I'm going to do a nice rounded curve, but then go straight through. And then I need to do a single root through the 0 that's at 1, right? So now I got to do a nice curve again and go straight up. Right, these are just sketches. They're not going to be completely accurate, obviously. It's just an idea of how it would look. Okay, let's do another one. Okay, so now this time I want us to sketch f of x is equal to 2x to the fourth plus 4x cubed minus 30x squared. I wasn't so nice this time. Why was I not so nice this time? Yeah, I didn't factor it for you. You're going to have to factor. Okay, so when we're factoring, what's the first thing we look for? GCF. So I'm going to pull out a GCF of 2x squared. So then we're left with x squared plus 2x minus 15. And now we'll keep on factoring. I set it equal to 0 so I can solve for the roots. So we have 2x squared, and then this is factorable, right? X plus 5, x minus 3. All right, 2x squared, single root, double root, triple root. What is it? Double root. What does a double root look like? A bounce, right? All right, so we're going to have a double root at x is equal to 0. X plus 5, single root, double root, triple root. Single root, which looks like a line at x equals negative 5. And then once again, x minus 3 is a single root, which looks like a line at 3. What was the original degree of this polynomial? What was the degree? Good. So the degree is 4. Was our leading coefficient positive or negative? All right, so if we're even, 4 is even, so if we're even and positive, we start which quadrant, end which quadrant? Good. Start 2 to 1, end. All right, let's plot our zeros. So we have x equals 0, we have x equals negative 5, 1, 2, 3, 4, 5. And we have x equals 3, 1, 2, 3. Okay, my furthest root to the left is negative 5. That is a single root. That is a straight line. But remember, I'm not coming up this time. Why am I not coming up this time to hit that root? Does anybody know why am I not doing this to hit this root? Good, because which quadrant are we supposed to start in? Quadrant 2. We're not starting in quadrant 3. So I'm not coming up to hit that root. What am I doing? I'm coming down to hit that root. All right, now I'm going to turn to hit the root at 0. But isn't the root at 0 a double root? So what does that mean when your root is a double root? You're going to hit the point, so you're going to hit the root, but you're not going to go through the point. You're not going to go through the root. You're going to hit the root and then bounce back down. And the last one, isn't it a single root? So I'm going to curve back up and go right through. Are we starting and ending in the right locations? Yes. Okay, let's do this one. It's a little fun, right? Okay, what have I done here? Our leading coefficient is negative. So what's the degree? The degree is 2. Leading coefficient is? So 2 is even. So we are even and negative. Hi, Jonathan. So we are even and negative. If we're even and negative, where are we starting? Where are we ending? You got it. Start, end. Okay. Do we all agree we're going to have to factor? Do we factor when the leading coefficient's negative? No, I'm going to pull out a GCF of what? Negative 1. X squared plus 5x minus 24. So then when we come to factor, we're going to get x plus 8, x minus 3. And then we're going to set each one equal to 0. Can negative 1 ever equal 0? No, so that's out. And then x plus 8 equals 0 when x equals negative 8. Do we all agree that's a single root? And then x minus 3 equals 0. That is a x equals 3. Again, a single root. Okay, so let's plot our roots. We're at negative 8. And we're at positive 3. And do you all agree we're starting in quadrant 3 and we're ending in quadrant 4? Since I'm starting in quadrant 3, I'm going to do a straight line through negative 8. But now don't I have to curve back down to do a single root through positive 3? And that's how we look. Should this look like a parabola? Absolutely, this should look like a parabola because it is. I'll give you one to try by yourself, and then that could be our last one. Okay, try this one.
I'm not.
Is this already factored? Yeah, it's already factored for you. So, to be completely honest with you, you will have to remember how to factor. There could be like factor by grouping on the test for these. There could be like, you know, GCFs or leading coefficient factoring. So you'll need to know how to factor. Just saying. Then I'll be very disappointed in you.
Do you have any test passes?
No.
You can only dream, man.
That would be nice, right?
Can a homework pass use for like one problem on the test?
No.
Can it be used for like extra credit on the quiz?
No.
Yeah, like 5 points.
Yeah.
No.
That's how it worked in like 3rd grade.
Who wants to come and teach this one? Chris, let everybody finish and then you could come up and teach it. Are we almost done? What time does this period end?
Can we invite Carter to teach it?
What'd you do?
Are you guys ready for Chris to teach you? All right, Chris.
Yes, Chris.
Go for it.
Where's the pen? Yeah? Okay, I'll do it as fast as I can. X.
You gotta teach us, Chris. You can't just do it.
Okay, we have x plus 3 equals 0, that's a 0, and we have x cubed equals 0, which is a 0. Wait. Right? Then x plus 3 equals 0, x equals negative 3, then this one's just x equals 0. Okay, and then you go down here, you have 0, you have 1, 2, 3, negative 3. It's an odd one, so you go from the third quadrant, you do the whoop and then the curvy line. And that's it.
Yeah, you did it. He did his disco dancer, sort of. Okay, so it should have been a double root, right? We had to hit the point and bounce back down for the double root. And then at x equals 0, that was a triple root. That was a disco dancer. So he tried. He tried to make his disco dancer there. With the curve. Yeah, I would take it. All right, we're done. Your homework is a worksheet.